Okay, guys, again, welcome. We are almost 40 people in the class right now. And then I might have at one point, it's a small quiz kind of thing. At any point, please try to focus on what I'm trying to explain to you. I'm sure you solved some questions about cumulative distribution function and other things. Until now, in the last 2 weeks, you were supposed to go over the slides and watch the videos. This will be a kind of review session with more exercises and then emphasizing some critical points. So random variables are like real numbers. For example, I'm rolling a die and I'm checking the output. I'm rolling a die and counting how many of the rolls have a number which is less than 3. Okay, these are kind of random variables and they are real numbers. If they are discrete, like if they don't have all the values but only certain values like 0 and 1, for example, we don't have any numbers here, then it is like discrete random variable. If it is like continuous like that, the random variable can take any number and the probabilities will change between 0 and 1, then this will be continuous random variable. This will be discrete random variable, okay? So we talked about probability mass function. This is probability mass function. What does probability mass function mean? It will show me what is the probability of each random variable. For example, the probability of obtaining 0 is, let's say, 1/3, and obtaining 1 is 2/3. Okay, this is a PMF. My random variables are 0 and 1, pass, fail, female, male, success, failure, kind of defective, non-defective kind of things we will call them 0 and 1, and each random variable will have a probability, and the total probability of these two things should be equal to 1. Okay, and then for continuous random variables, we will start talking about this today, and I'm sure you went over the slides and the videos on continuous random variables, different types of continuous random variables, such as uniform random variable, Gaussian random variable, exponential, chi-squared, and so on. So these are some things that we will also be using in the statistics part of the course. So it's kind of, the course is divided into 2 parts. The first part is about probability. The second part is about statistics, okay? So starting from 2 weeks from now, we will start the discussion of statistics, some tests. What does statistics mean? Why do we do it? What kind of statistical experiments, statistical tests we do for answering some hypotheses, answering some questions about a certain data set or certain, let's say, numbers or data that we have, okay? So at this point, I'm gonna focus on cumulative distribution function. Like this is probability mass function. You know, probability mass function, as I said, is like discrete like that. This is my random variable, and this is my possible outcomes, 0 and 1. And then this is 1/3 and 2/3, as I mentioned here. And then now I would like to convert this into a continuous function, okay? So cumulative distribution function is a kind of, cumulative means addition, okay? I'm adding up, like accumulator, it's adding up ions, okay? Cumulative is like adding up probabilities to obtain a continuous function, okay? For example, I will say if my probability is less than 0, what is the probability of obtaining a number which is less than 0? It is 0, right? So before 0, it will be 0. At 0, it will be 1/3, until between 0 and 1, until 1, it will be 1/3. So there will be a jump here, okay? And then it will be like 1/3 here. There will be a kind of hole here, and it will continue like this until I reach 1, okay? This is 0, this is 1. And then there will be another jump here, and then it will continue as 1 from here. So this jump is like 1/3, and this jump is 2/3, and finally I will have, this is 1/3, this is 1, okay? I'm adding up. Until this point, what is the probability? 1/3. After that point, what is the total probability? 1/3 plus 2/3, so it will be 1. And after 1, it will always be 1, right? So if I say, what's the probability of obtaining a number which is greater than 1, okay? Probability of obtaining a number greater than 1. So all the numbers are greater than 1, right? So it is either 0 and 1, so the probability will be 1. So I'm going to come to the cumulative distribution function and then say, oh, if it is greater than 1, so it is always 1 like that. For example, if the probability is between 0 and 1, then I'm going to say, I'm going to come here, it will be somewhere here, and then it will be 1/3, okay? So I will be able to calculate probabilities using the continuous or cumulative distribution function, okay? PMFs are discrete. I don't have a continuous characteristics there. The probability theory tells us, gives us another representation of the probabilities given as cumulative distribution function, which is CDF, okay? So in MATLAB, you can see CDF also. CDF is adding up all the probabilities as I go from some initial point until the last point, okay? So this is actually the definition of CDF, probability of my random variable being less than or equal to a number, okay? This is like probability of x less than 1, for example. Probability of x less than or equal to 2, for example, okay? This small x is a number. This is my random variable. This is my random variable, and this is defined as CDF of 1, for example. You see, this 1 is here. This capital F is called CDF. Okay, guys. So this is probability. I'm gonna come up with the CDF. Okay, this is the CDF. This is the probability of a random variable being less than or equal to a number, okay? As I said, for example, I was either using failure or pass, and then I was able to count the probabilities or find out the probabilities and come up with the CDF, okay? For example, now using this formulation, guys, let me write the formulation again. This is capital X, this is small x, and this is my probability x less than x. Let's focus on this exercise right now. I'm tossing a coin twice, okay? I'm tossing a coin twice, and I'm after the number of observed heads, okay? I'm tossing a coin twice and counting how many heads I have. This is my random variable. And then I'm now obliged to find the CDF of x, okay? How do I do this? Everything, is this a continuous or a discrete random variable? Arkadaşlar?
Discrete hocam.
This is a discrete random variable because it is like number of observed heads, okay? It can only take discrete values like 1, 2, 0, okay? Toss a coin twice. So I might have 0 heads. I might have 1 heads or 2 heads, right? Because I'm flipping it twice. What's the probability of obtaining 0 heads? What's the probability of obtaining 0 heads arkadaşlar?
1/4.
When I flip a coin, okay, twice, it will either be it will either be heads or tails. Obtaining no heads is like twice obtaining tails twice, right? It is 1/4. What's the probability of obtaining 1 heads? 1/4 plus 1/4, right? In the first probability, let's say it's going to be 1/4, and the second one it's 1/4. So what's the probability of obtaining 2 heads? Again, 1/4, right? So by knowing these, now I want you to find out probability of cumulative distribution function of, for example, -1. What is cumulative distribution function of -1? What does it mean? What does it mean? Probability of my random variable being less than or equal to -1, right? If you can relate these two, then you can understand what's going on. Okay, what is this? What is the CDF -1, guys?
0.
0, right? There is no probability of obtaining -1 heads. What's the probability of like CDF of -0.5? -0.5. Again 0, right? Again 0. Why? Because my range starts from 0, 1, and 2, right? This is my range. These are the only random variables I can get. So if I say if this x value is less than 0, okay, if probability of x less than or equal to less than 0, not equal to, less than 0, okay, what is the value? It is always 0, right? The probability of obtaining no heads less than 0 is always 0. So how can you come up with a CDF? So I'm gonna write, this is my x value, okay? X values are these ones, okay? These ones. So before 0, it is 0. Okay, this is 0. At 0, it is 1/4. Okay, it is 0 at 1/4. A number between 0 and 1, for example, 0.5. What is the probability of obtaining a random variable less than or equal to 0.5? What is the possible value that I can get? Only this one, right? Guys, are you with me? Are you following me, guys, or you're sleeping? What's going on?
Hocam.
You're
We are
here? Yes. Okay. Hopefully. Let me see your faces, arkadaşlar. Turn on your cameras, please. Let me see your faces. Şimdi, what is the probability of obtaining a random variable less than or equal to 1.1, for example, or 0.5? Let's continue with this, 0.5. So what is the probability of obtaining a random variable less than or equal to 0.5? This is the only thing, right? It is 1/4. So same thing with this one. This is 1/4. Until which value it's going to be 1/4? Until 1. If this reaches 0.99, then it is still 1/4. When this reaches 1, arkadaşlar, and probability of x less than or equal to 1, then it becomes this one plus this one, okay? Why? Because it is the probability of obtaining x less than or equal to 1. So this includes probability of x equals 0 plus probability of x equals 1, right? Do you understand this point, arkadaşlar? Both 0 and 1. I'm going to add these two, which is going to be 1 over 4 plus 1 over 2. So it will be 3 over 4. Until which point? Until 2, okay? But you see, there is a hole here. There is a filled hole here, okay? Why? Because at 1, 1 is only included here, and after that point it is included here. And at 2, what is the probability of obtaining a random variable less than or equal to 1.99? What is the probability of obtaining x less than or equal to 1.99?
1.
It is still 3 over 4, right? Until this point, it is still 3 over 4. It didn't touch 2 because it is this thing has not been included in the CDF yet. When I say probability of x less than or equal to 2, then this one comes into play. Then I'm going to add it up, and then at 2, it will be equal to 1, okay? And from after that point on, it will always be 1. So probability of obtaining a random variable less than or equal to 3 is equal to probability of x less than or equal to 5 is equal to 1, okay? A number, a random variable, obtaining 3 and above, 2 and above is always 1. Why? Because it means, what's the probability of obtaining heads that are less than or equal to 2? Either it's 0 heads, or 1 heads, or 2 heads, right? 3 options. I don't have an option and a probability, a random variable, which is 3, because I'm only tossing it twice. So number of heads less than this, less than or equal to thing, makes it critical, okay? And it becomes like a continuous function, okay? So I might have probability of x less than or equal to 1.0012, right? So that means it's continuous. It can have any number, but PMF for this 1 over 4, 1 over 2, 1 over 4. It is only 3 options and some probability values. But this is PMF. But CDF is a continuous function. Okay? So there will be a question next week, inshallah. I will give you a random experiment like that. I will want you to find out the PMF and then calculate the CDF and then calculate the continuous or cumulative density or distribution function, okay? So it will be a kind of part A PMF, part B CDF, part C expected value, and so on, okay? So is everybody clear on this, arkadaşlar? The CDF concept is based on this formulation. The critical part is this. This is a number, okay? This is a number on x-axis, okay? This is a number on x-axis. This is my random variable, and I'm trying to find out the probability of that random variable being less than or equal to a number, okay? And this number will be seen as a function of CDF, okay? CDF is shown as capital F, okay? So I hope you got the main idea here. And this is the solutions. Let me show once again. Until 0, it is 0. After 0 and between 1 and 0, it is 1 over 4. Between 1 and 2, it is 3 over 4, and after 2, it is always 1. You can see that this jumps, arkadaşlar, is equal to the probabilities at certain random variable points. Okay? Probability of x equals 0 is 1 over 4. Probability of x equals 1 is this jump. What is this jump? 3 over 4 minus 1 over 4, it is 2 over 4 or 1 over 2. Okay? And what's the jump here? 1 over 4. So by looking at CDF, you can find out the probability values at certain random variable points like 0, 1, and 2. It is always an increasing function because I'm adding up, accumulating the probabilities. So I'm adding up. Okay, that's why it's an increasing function. And then by showing that, for example, you see for x less than 0, this is the function way of showing things. This is the graphical way of showing things. Okay, after 2 and greater than or equal to 2, the CDF is 1. That means all the probabilities are already included. Okay, so I hope you got the main idea here. This is also important because you're gonna now solve certain questions at this point. Arkadaşlar, let's do the questions and then let me give you this exercise right now. I want you to solve this question on your papers and give me the answer through chat recording. Now we will continue with joint probability distributions. What does joint probability distributions mean? We might have more than one random variables, okay? And they can be related to each other. They can affect each other. For example, for a random family, we would like to study the number of people in the family, the household income, the ages of the family members, right? So these are all related to each other and they are dependent, okay? They are dependent. That means they are related to each other. And that's why we might have more than one random variables in a random experiment. So there might be more than one random variables. So if I have more than one random variables, my PMF, my probability mass function, will have a different style, okay? For example, this is a probability mass functions representation, P of X and Y, and X, Y. What does it mean? I have two random variables, X and Y. For example, the number of people in the family, let's say the ages of the people in the family, okay? So that means probability of X equals X and probability of Y equals Y, and we have to consider them together. If I'm saying joint, that means birleşik, okay? Birleşik olasılık fonksiyonu. So there is a kind of joint situation here. All the probabilities, when I add them up, it should add up to 1. Okay? For example, arkadaşlar, I can give you such an example. For example, if X is equal to 0, okay, let me make it a little bit bigger. If X is equal to 0, there are 3 options. Okay, Y is equal to 0, Y is equal to 1, Y is equal to 2. What does it mean, guys? I might have X being 0 or 1. These are the 2 options that I might have in terms of X. Pass and failure, okay? Success and failure, male, female. There is another category. For example, let's say this is male, this is female, okay? And there are other categories. For example, this is from electrical engineering. This is from computer engineering. This is from mechanical engineering, okay? 3 different categories and 2 different male, female, let's say random variable, okay? I might have male student from computer engineering, female student from mechanical engineering, okay? So I might be interested in the joint PMF of these, okay? For example, if I have such a question, find P of x equals 0 and y equals less than or equal to 1. What does it mean? It will be probability of x equals 0 and probability of y equals 0 plus probability of x equals 0 and y equals 1, right? You see, y is less than or equal to 1, so it will be 0 and 1. X is always 0, so this is this. What does it mean? Probability of a male student being from either computer engineering or electrical engineering, okay? What is the probability? So it is easy. I will come x is equal to 0, y is equal to 0. This number, it is 1 over 16. 1 over 6, sorry. So this is 1 over 6. Plus this one, probability x equals 0 and y equals 1. This one, 1 over 4. And it will be totally 2, 3, 5 over 12. Okay? So if I want to find out a joint PMF, okay, this is a joint PMF because it includes two random variables. One of them is x and the other one is y. And I am given a table of probabilities for each possible combination. You see, mechanical engineering student, female engineering, it is 1 over 16. Female student, computer engineering, 1 over 4. Okay, so it's a kind of joint probabilities of two random variables. Okay, if I want to tell you one other concept which is called marginal PMF, then I'm going to say, what is the probability of x? Okay, x equals, for example, probability of x equals 0 and for all y's. Okay, okay, that's called marginal PMF of x. Okay, probability of x equals 1 and all y's. Then it is called marginal PMF. Okay, normally I have marginal PMF of x and marginal PMF of y. Okay, so normally I might have a PMF of x, but if I have joint PMFs, joint probabilities, then I may focus on only one of the random variables. Okay, for example, I will focus on only this one, probability of x equals 0. Okay, so for this joint PMF, what should I do? I'm going to add this plus this plus this, right? These are all probabilities, which is probability of x equals 0 and y equals 0, plus probability of x equals 0, y equals 1, plus probability of x equals 0, y equals 2. Okay? This is what? Marginal PMF. Marginal PMF. If I have a joint PMF, I can come up with joint PMF calculations, or I can have a marginal PMF. That means I can only focus on x or y. For example, can you tell me what's the marginal PMF of y equals 0, guys, for this question? What is the marginal PMF of y equals 0? This time, I'm gonna add these, right? I'm gonna add these two because it's only y equals 0. So I'm gonna say probability of x equals 0, y equals 0, plus probability of x equals 1, y equals 0. I'm keeping y equals 0 here and changing x equals 0 and x equals 1. So 1 over 6 plus 1 over 8. Okay, 14 over 48. or let's say 7/24. Is that clear arkadaşlar? Is this clear? Marginal PMF concept. I am going to focus on one of the random variables, find out probabilities of those random variables. Then it's called marginal PMF. If I'm only interested in joint PMFs, joint probabilities, then I should focus on such examples. Okay. So let me. So, for example, again, the same example, okay? Find the marginal PMFs of X and Y. How can I find it? X equals 0. You see, X 0, 0, 0, 1, 0, 2. I'm adding these three and find out X equals 0. Okay, it is 13/24. And I'm going to do the same thing for this one. I'm going to add these two and find out this is marginal PMF of X. Okay. Add these right here. Add these right here. And say X equals 0, X equals 1. Otherwise, it is 0. For Y, I'm going to add these two, obtain 7/24. Add these two, obtain 5/12. Add these two, obtain 7/24 for three different cases. Okay. This is again marginal PMF of Y. Easy, right? It's not a problem.
Hocam, can I ask something?
Sure. Yes, Enes, please.
Hocam, in this question, how can I find the probability of, for example, px smaller than y, for example?
Px smaller than y, right?
Yes, hocam.
So, for example, here I'm gonna write probability of x equals 0, y equals 1. Probability of plus probability of x equals 1 and y equals 2. Right? These are, and also probability of x equals 0, y equals 2. These are the three options, right? If this is 0, it can be either 1 and 2. If this is 1, it can be only 2. So these three probabilities will make up this probability, which is y equals 0, y equals 1, this one, 1/4. Let me go here, 1/4, plus x equals 1, y equals 2, x equals 1, y equals 2, this one, 1/6, plus x equals 0, y equals 2, 1/8. Okay, so it will be 4, 2, 3, 6, 4, 3, 13/24. Enes, is that correct? What do you think?
Yes, hocam, I think correct.
Okay.
Thank you.
So this is like probability of x less than y. I'm going to check the numbers and try to come up with the combinations, the joint probabilities accordingly. So is x here, x is 0, y is 1. So this is correct. X is 1, y is 2, again correct. X is 0, y is 2. So if it is like 1, probability of x equals 1 and y equals 1, it is not correct, right? Because x should be less than y. Okay, I hope we got the main idea. Now let's focus on this question, guys. Can you solve this question? Probability of y equals 1, given that, conditional probability, given that x equals 0. Do you remember the probability of A given B? What was the probability of A given B? Probability of A and B divided by probability of B, right? Is this clear? Arkadaşlar, conditional probability, do you remember this? A given B, I'm gonna say this is A and B divided by B. So what is the probability of y equals 1 and x equals 0 divided by probability of x equals 0? Probability of x equals 0 is a marginal PMF. And y equals 1 and x equals 0. Y equals 1, x equals 0. So this is 1 over 4, 1 over 4. What is x probability of x equals 0? The whole thing. Right? 1 over 6 plus 1 over 4 plus 1 over 8. So 1 over 4 divided by 7 over 24, right? 3. This is 4. This is 3. Sorry, this is 6. 4, 6, 13 over 24. So it will be 1 over 4 times 24 over 13. It is 6 over 13. Did everybody understand how did I solve this question, arkadaşlar? For example, if I ask you, find probability of y x equals 2 given, sorry, x equals 1 given y equals 1. Can you tell me the answer? X equals 1, y equals 1, given. Okay. I'm expecting your answers. Okay, I'm getting good answers. Thank you very much. So it means probability of x equals 1 and y equals 1. What is this? This one, right? 1 over 6. Divided by probability of y equals 1, which is the whole thing, 1 over 6, 1 over 4 plus 1 over 6. So it will be 1 over 6 divided by 3, 2, 5 over 12, 1 over 6 times 12 over 5, 2 over 5. Easy, right, arkadaşlar? I'm sure you got the main idea, hopefully. So marginal probability and joint probabilities are kind of easy concepts in PMFs. You can easily solve these questions and then find out the answers, okay? So, yes.
Is it possible to say p x equal to 1 and y bigger than something, or using?
Sure, yes. It is possible. For example, if you say x equals 1, y less than, let's say, less than or equal to 1, okay? Then I'm gonna come up with this solution. I'm gonna focus on this one, probability of y less than or equal to 1. Then I'm gonna say it is probability of y equals 0 plus probability of y equals 1. So I'm gonna add these two columns then, okay? So it is always possible, but here also you have to write probability of x equals 1 and y equals 0 plus probability of x equals 1 and y equals 1. So you have to consider both in the upper part, this part, and in the lower part, while considering this less than or equal to or greater than or something, okay? Is this clear? So Berke, is this clear?
Yes, hocam.
Yes, okay.
Thank you.
Welcome. Okay, guys. So you have been considering continuous random variables, or you worked on them in the last couple of weeks. So we will consider continuous random variables for the last half an hour or so. So we will be considering continuous random variables and cumulative distribution function. Okay. For example, arkadaşlar, if I wanna generate a random number between 0 and 1, okay, is it a continuous random variable? I'm gonna randomly generate, okay, random number generator between 0 and 1. Is it a continuous random variable or a discrete random variable? It can be any number, right? So it can be 0.9952, or it can be 0.00134, right? So any number in this range can be obtained by a random number generator, for example. So continuous random variable it is, right? For example, if I want to measure your height, it will be like between, let's say, 155 up to 195 centimeters, for example, 155, 195 centimeters. It's again a continuous random variable. So in our data that we are dealing with, for example, a signal like this, right? An ECG signal, something like that, or an EEG signal, or a kind of, let's say, sinusoidal signal is always a kind of continuous function. But what is critical here? Random variables should come out of random experiments, okay? So I cannot say my sine wave is a kind of random variable. No, my sine wave is not a random variable. It is already a function of t, okay? I know it, it's like sine 2 pi ft. So it is already deterministic signal. I don't have any randomness in that. But in an ECG signal or an EEG signal or a sensor data, okay, temperature data or something like that, it is random. We don't know, we cannot know it for sure what the temperature will be at this location at this time instant. So it is a random signal. So as an electrical engineer or a computer engineer or mechanical engineer, if we are dealing with sensor data, if we are dealing with, let's say, certain continuous functions that we have been focusing on in our professions, they are usually random signals and random variables, and we talk about their probabilities and so on. So in continuous random variables, we have a range in the form of an interval or a union of non-overlapping intervals in the real line, okay? Possibly the whole real line. So we will be talking about all real numbers, for example, between 1 and 2, all real numbers, okay? Between 0 and 100, all real numbers, for example, your grades, okay? It might be 11.5, 50.25, or so on. So they might be any number between 0 and 100. So grades are usually talked about as random variables, continuous random variables. In PMFs, arkadaşlar, we were always talking about sums, but in continuous random variables, we will be talking about probability density function and integrals, okay? Not sums, but integrals. What did we say? Probability of x less than or equal to x. For example, in cumulative distribution function, what did we say? X equals 0 plus x equals 1, and so on. But in continuous random variables, we will not add them up, but we will come up with a integral, okay? Arkadaşlar, there is one trick about continuous random variables. We don't say, for example, I have a random variable, okay, between 0 and 1. Okay, I have a random number generator in MATLAB. It can generate any number between 0 and 1. It may be either 0.1, 2, 5, 0, 2, or it may be 0.7, 3, 5, 3, 1, okay? It may be any number like that. So in continuous random variables, arkadaşlar, I cannot say what is the probability of obtaining x equals 0.5, okay? We don't say that. There is no probability of x equals 0.5. In continuous random variables, we say what is the probability of obtaining a number in this range, for example, between 0.4 and 0.5. Okay? This is critical. I want you to understand that part clearly. We don't say what is the probability of x, my random variable, being equal to 0.4 for continuous, 0.5 for continuous random variables. It's not possible like that. Instead, I say probability of x between 0.4 and 0.5. Usually we don't put equals here because we don't deal with exactly equal numbers for continuous random variables. Okay, so it is about length of an interval. For example, what is the probability? For example, arkadaşlar, I have a uniformly distributed random variable. Okay, that means my uniform distributed random variables PDF is something like that. Okay, this is my PDF probability density function. This is what we call for continuous random variables, if you remember. And it is between, let's say, if I have a number between 1 and 2, and let's say it is between 0 and 2, okay, not 1. Okay, let me come back here. It is between 0 and 2, and the area under this thing should be equal to 1. So I will write 1/2 here, right? So the area under the PDF should be equal to 1. So let's say the PDF is f of x, okay? The area under this f of x should be equal to 1. So the total, we were writing as probability of x equals to 1, right? In PMFs, we were adding up all the probabilities, discrete random variables, probabilities should add up to 1. But in continuous random variables, we don't add them up. We use integration, okay? Integration is a different way of adding up. So the area under the continuous random variable PDF, it should be equal to 1. So if this is between 0 and 2, this thing should be equal to 1, right? 1/2. If, for example, if I have a random uniform distributed random variable between 1 and 3, what is this value? What is this value? It is again 1/2, right? So this part is 2. 2 times 1/2 should be equal to 1. The area should be equal to 1. So what does that mean? For example, if I have a random variable between 0 and 2, and this is 1/2, this is x, this is the PDF. What is the probability of obtaining a number between 0 and 1? What is the probability of obtaining a number between 0 and 1? And my random variable is, the range is between 0 and 2. So I'm only interested in this part. What is the probability, arkadaşlar? 1/2, right? So half of the length. The whole length is 2. And I'm interested in half the length, so the probability is 1/2. You can check that in MATLAB, arkadaşlar. For example, you can generate numbers between 0 and 1. Let's say 10,000 numbers. Okay, 10,000 real numbers between 0 and 1. And then you can find out that almost half of this 10,000 numbers, almost 5,000 of them, will be between 0 and 0.5. And the other half will be between 0.5 and 1. So what does that mean? If I am interested in the probability of a certain interval, I cannot say probability of x equals this. No, I have to always be talking about probability of an interval between this number and this number. Okay, in continuous random variables, that's the trick. Okay, for example, if I have that kind of an exponential random variable, for example, okay, this is my x, this is my PDF, and I might be interested in, and the range is between 0 and infinity, I might be interested in only the values on the probability between 0 and 1. What should I do? What should I do? I will write f of x dx between 0 and 1. Okay, so this will be a kind of probability of x between 0 and 1. Do you understand what I'm talking about, guys? Do you understand what I'm talking about? In any kind of probability density function, which we will call fx of x, there might be different representations, but let's say this is the PDF of a continuous random variable. If I want to find out the probability of a certain random variable, I have to deal with integration. Okay, for example, let's come up with one example. Let me come here. Okay, I want you to deal with this question right now. This is my PDF. This is how it is determined, c times e to the power minus x. So it's an exponential. It's an exponential random variable. Okay, this is x, and this is fx of x. Okay, after 0, it is this number, and then what should be the area under this curve, arkadaşlar? It should be 1. Okay, so how do I find c? I'm gonna come and say, okay, between 0 and infinity, c times e to the power minus x dx should be equal to 1. Okay, did everybody understand this part? I am writing fx of x, my PDF, probability density function. The integration, the value, the area under this curve should be equal to 1. What does the area under the curve mean? Integration, right? That's the definition of integration, integrals. So I'm going to come here and find out the integral. It is minus c e to the power minus x from 0 to infinity. Right? The integral of e to the power minus x is minus e to the power minus x, and c is going to be here, and it should be equal to 1. Then I'm going to put infinity here, minus c e to the power minus infinity, minus, okay, minus c e to the power 0 should be equal to 1. So e to the power minus infinity is 0. So this part is gone. So I will have minus minus plus c times e to the power 0 should be equal to 1. And c This is also equal to 1. C is 1, right? So the C is equal to 1. That means the PDF is going to be equal to e to the power minus x for x greater than 0. Otherwise, it is 0. So I found my PDF by finding C using the area under the curve concept. Burası anlaşıldı mı arkadaşlar? The area under the PDF function should be equal to 1 for continuous random variables. For discrete random variables, all probabilities of random variables should add up to 1. Okay? That's the difference between continuous random variables and discrete random variables. Again, now let's go back to the CDF. What was the definition of CDF? What was the definition of CDF? Here is the definition of CDF. I will, this time, what was my definition in using PMFs? It was like that, right? In discrete random variables, it was like that. The probability of x less than or equal to x. So I should do the same thing for continuous random variables. This time I'm going to write not the probabilities. I'm not going to use the probabilities, but this time probability density function. Okay, u du from minus infinity to x. So I will have, let's say, this exponential function, okay, my PDF. It is from 1, and the area under this is 1, from 0 to infinity, and this part is 0. Okay, this is my PDF. And what does this say? This tells me that I should do the integration. And integration, what does integration do? I'm going to take, again, a window between minus infinity to here, it is always 0. And here, I'm going to find out the integral between 0, let's say 1, and e to the power minus x dx. Okay, the probability of this random variable between 0 and 1 is the area under this curve. The probability of between 0 and 2, it is going to be 0 and 2 e to the power minus x dx, right? So it will start with this one. Let's do it. Minus e to the power minus x from 0 to 1. If I put 1 here, minus e to the power minus 1, minus minus plus e to the power 0. So it will be 1 minus 1 over e. Okay? So it will be 1 minus 1 over e. It will start here. 1 minus 1 over e. And then my CDF will add up and come back to 1. Okay, the area will increase. The area under this curve will increase as I go further, and it will reach 1 at infinity. Okay, this is the CDF. This is the PDF of continuous random variable. Okay, is that clear, guys? So let me write it in a better. Here is the explanation. You can see that I am doing the integral from minus infinity to x. Okay, so x is my CDF. This is CDF. So what does it mean? That was my PDF, and I will go from minus infinity to x. X is here, for example. What is the integral between minus infinity to x of this function? This area. And then if I increase x, I will go here. Let me write it with a different color. I'm going to go here. If x is this, so the area under this one If I go here, it will be this one. So as I go further, okay, as I go further to plus infinity, the area under this one will be equal to 1. So my CDF will be like this. Okay, at infinity it will be 1. Starting at 1, at 0, it will be 0. Sorry, it should come here. At 0, it is 0. And then as I go further, it will be increasing and increasing. You see, CDF is an increasing function. Okay. So here is the CDF for our exponential function, this one. Okay, as I increase x, this value will go down and I will be close to 1. E to the power minus x. As x goes to infinity, this will go to 0. Okay. If x is like 1, 2, there will be a number here. So 1 minus that number will be something like that. And then as I go further and further, it will reach up to 1. Okay, so this is my CDF. And using the CDF, I can find out the probabilities like that. Okay. So if probability between 1 and 3, so what does this mean? I have this PDF, and between 1 and 3, what is the probability of obtaining a number between 1 and 3? How do I do it? What does this mean? The area, CDF of 3 means the area here minus CDF of 1, the area here. Okay, what is left? This part is left between 1 and 3. Okay, so if you understand this probability of my random variable between 1 and 3, it's going to be 3 CDF of 3, which is the area under the curve until 3. This is the area under the curve until 1. So if I subtract these two, I'm going to obtain the area between 1 and 3.
Hocam,
Yes.
isn't we check this from CDF?
The probability you mean?
This question, between 1 and 3.
1 and 3, yes.
I guess we need to check it from CDF graph and its function.
But this CDF is already related to this, right? So you can do this both ways. A good question. So I have 2 graphs, right? One of them is my PDF, like this. The other one is CDF, like that, right? It reaches 1. It goes from 1 to down. Okay, this is X, this is X. This is CDF, this is PDF. Okay, PDF, CDF. I can do 2 things. If it is like probability of X between 1 and 3, I can come here and then find out the area between this. Okay, how can I do it? Fx of X between 1 and 3. One option is this, right? And what does this mean actually? Between minus infinity to 3 minus infinity to 1, right? So minus infinity to 3 minus infinity to 1, I will be left with between 1 and 2, 1 and 3, right? It's going to be equal to 1 and 3. These are coming from integral properties. So what does this mean? CDF of 3. What does this mean? CDF of 1. I can use both PDF in finding probabilities and also CDF. What's the advantage of CDF? CDF is like directly you can, if you find CDF like that, you can directly put numbers and find out the probabilities. How do I do it? Probability of 1 to 3. This is e to the power minus 1 minus e to the power minus 3. Or you can put here 1 minus e to the power minus 3 minus 1 minus e to the power minus 1. So this is f of x of 1, f of x of 3. If I subtract these two, I'm going to get this probability. Is this clear? I can find out the probabilities using either the integrals of PDFs or directly from the continuous cumulative distribution function. Is this clear?
Yes, hocam.
So let me write once again. If I want to find out the probability, okay, this is the question for you. Probability of x less than 1. Find out the probability of x less than 1. F of x is equal to e to the power x minus x and 0 if x is greater than 0 and otherwise. What's the probability of x less than 1? What's the probability of x less than 1? What should I write? Abdul Kadir, what should I write? What should be the integral like? Abdul Kadir Çetin.
Minus infinity to
Minus infinity
X.
to
x and fx
fx of x, you see, huh?
yeah.
You say. But what is a specific? This is the general. This is the general. Let's say definition of CDF, right? This is the general definition of CDF. But my question is, what's the probability of x less than 1? What's the probability of x less than 1? My random variable being less than 1. So can I write it like this? Between 0 and 1, e to the power minus x dx, right? I can write it like that, right? So because I'm interested in this area, so I can write minus e to the power minus x from 0 to 1. It's going to be 1 minus e to the power minus x minus 1, which is 1 minus 1 over e. Okay? Arkadaşlar, is this clear? For example, if I have a uniform distribution between 1 and 2, okay, this is my PDF. And I want you to find out the probability of x between 0.5 and 0.6. Sorry, 1.5 and 1.6. Probability of my random variable between 1.5 and 1.6. How can I find that? Arkadaşlar, yes, Mustafa Berke.
Hocam, I want to have something
Sure.
more. Now, we are saying generally otherwise 0. Can we
Yes.
say otherwise minus 2? Is it possible?
It is possible. For example, if you might have something like that, for example, you might have such a PDF, for example. Okay, there might be before 0, it might be something like that, and after that, but you should be careful, because, for example, if I have otherwise it is equal to 1/2, then the area under this will be equal to infinity, right? The area under the PDF should always be equal to 1. You have to be careful on that. Okay, that's why otherwise, if it is 1/2, otherwise means, for example, let us do it, e to the power minus x 1/2. Okay, so it will be something like that. So the area here is 1/2, and there should be another 1/2. So, for example, I can do it like that. This 1 over, let's say 1 minus 1 over minus 1, and this will be 1/2. I cannot say otherwise everything, right? Because then the area under the curve might converge to infinity. That's the risk over there. But I can have something like that. After, for example, x greater than or equal to 0, e to the power minus x 1/2, and between minus 1 and 0, it may be 1/2. Otherwise, that means less than minus 1, it should be 0. Is that clear? So this is a critical point. You always have to check your area under your PDF converging to 1. The addition or integration of all PDF areas, the area under the PDF curve should always be equal to 1. Okay, otherwise it is not a correct PDF. Mustafa Berke, is that clear for you?
Yes, hocam. Thanks so much.
Okay, you're welcome. So, arkadaşlar, there are many examples on that, and we might solve questions on that next week. But let me check. Let me check one question here. These are all about variance and so on. So there might be. Okay, let me. So let us focus on this question right now. This is my PDF. Okay, f of x, 2x between 0 and 1. Is this a PDF or not? How can I make sure this is a PDF or not? Let me draw this. Okay, between 0 and 1, it should be 2x. What is the area under this curve? 1 times 2 divided by 2. 1 times 2 divided by 2, which is 1. So, correct. This is a PDF. This is a valid PDF. How did I check this, guys? I wanted to find out the area under this curve. This is my PDF, and the area under this curve is 1, because it is between 0 and 1. 1. It is a perpendicular triangle. So the area under the triangle is the area of the triangle is 1, right? So this is my PDF. Can you find out the probability of x being 0 and 1/2? What's the probability of x being between 0 and 1/2? Here is the trick, arkadaşlar. It's very easy. I'm going to come here and write 1/3 here, 0 here, x here. This is my PDF. Find out the area here. Okay? What's the area? This is 1. This is 1 over 2. 1 over 2 times 1 times 1 over 2, which is 1 over 4. So the probability is 1 over 4. The whole area is 1. Only 1/4 of it is between 1 and 0 and 1 over 2. Okay? Because the area here is 1 over 2 times 1 divided by 2, which is 1 over 4. So the probability of obtaining a number between 0 and 1 over 2 is 1 over 4. Is this clear, guys? What's the probability of x greater than 1 over 2? What's the probability of x greater than 1 over 2?
3 over 4.
3 over 4.
3 over 4, right? So this is the remaining part. So this part is about x greater than 1 over 2, right? So I should be focusing on probability density function, the function itself, and draw it if possible, if it is easy to draw. If it is not easy to draw, then deal with the integration. I'm going to do the same thing between 0 and 1 over 2. Write this 2x dx. This is my probability density function. And I'm going to find out the probability. What is this probability? This one. Probability of x between 0 and 1 over 2. 0 and 1 over 2. And what's the integral? X squared between 0 and 1 over 2. Put 1 over 2 here, 1 over 4 minus 0, which is 1 over 4. Is this clear, guys? So I can do it by looking at PDF and drawing everything in PDF graph. If it is not easy to draw, then go and find out the integral between 0 and 1 over 2. Okay? So what is the CDF of this? What is the CDF of this? How can I find it? Between minus infinity to x, I'm going to write 2u du, and this is going to be my CDF. Why am I going to u? Because the integral boundary is x, right? I cannot put x here. It should be changed to u so that I will be able to put x in place. Okay? So if I put I don't need minus infinity because it is like 0 all over the place. So I'm going to put 0 here. So it is u squared. The integral of 2u is u squared between 0 and x. And it is x squared minus 0. So the CDF is x squared for x is between 0 and 1. Otherwise, it is 0. So it will be something like that. Okay, it will be something like that, x squared. So until that point, it will reach up to 1, and then after that, it will be equal to 1. Okay. Is this clear, guys? How I find out the CDF and how I draw it between 0 and 1? Otherwise, it should be not 0. It should be 1. Okay. After like before 0. So let me write x less than 0. It should be 0. X greater than 1. It should be equal to 1. Okay, so if you take the integral of this, it will be 0 and then increase and reach 1, and it will be always 1 after a value which is 1. Okay, so I hope you got the main idea, arkadaşlar. So this is the variance. I know that some of you have midterm on OHS. You can leave. I'm going to finish in 5 minutes. I'm going to go over the expected value and variance and then finish here. Okay. Arkadaşlar, expected value is something that we will be using also in coming parts of this course. So I want you to understand the basic idea behind it, okay? For example, how can I find the mean or average age of this group in this class? How can I find the average age? I will add up all the ages and divide by the number of people, right? So I'm going to add, let's say 21, 22, 20, 19, 23, 40. Like I'm going to add 1, 2, 3, 4, 5, 6 people and then obtain the summation and divide by 6. So this will be my average age, okay? So normally, while finding means or averages, we do this, divide by 6, divide by the number of people that I'm using, divide by the number of data that I'm adding up, okay? But if the probability of different data points are different, then I'm going to use expected value using this formulation, okay? Expected value can be written as this, or this, or this, okay? Different notations can be used. But the whole idea is summing up for discrete random variables, okay? I'm going to add up the value, xk is my value, and then the probability of that value, okay? For example, arkadaşlar, if I roll a die, okay, what is the expected value for rolling a die? I'm going to find it out like this. What are the possible options? 1, 2, 3, 4, 5, 6. What is the probability of obtaining 1? 1 over 6. What's the probability of obtaining 2? 1 over 6. What was the 1 over 6, and so on, 1 over 6. What am I going to do? 1 over 6 times 1 plus 1 over 6 times 2, and so on, and 1 over 6 times 6, which is 3.5. This is my expected value. This is my mean. This is my average, okay? 3.5. How did I find it? The value, probability. Value times probability. Value times probability. For example, if I have a class, okay, and let's say there are 50 students in the class, and like 30 of them passed the class, and 20 of them failed the class, okay? What is the expected value for this random experiment? So I'm going to come and find out, let's say pass is 1, fail is 0. What's the probability of pass? 3 over 5. What's the probability of fail? 2 over 5. How do I find the expected value? 1 times 3 over 5 plus 0 times 2 over 5, which is 3 over 5. Okay? So expected value, finding the expected value is highly easy. Okay? So you may find it out for different distributions, and you have already covered them. And then variance is,
Hocam,
yes.
for example, we are tossing a coin, and we need to say something to probability, right? For example, in the previous example, we said 0 or 1 for passing and
Yes. It's our
falling.
definition. We can say 1
Yeah.
and 2. It's our definition.
Is it the same with that?
Yes. but we have to be, your question is this, right? For example, if I have one for pass, let's say female 1, male 2, okay? And obtaining a female student in the class, probability is 1/6. This is 5/6. What is the expected value? According to these definitions, I have to multiply these 1/6. I have to multiply these 10/6, okay? And then add these two, 11/6 is my expected value. Okay, it all depends on your definition, but you should stick to your definition carefully. Okay, you cannot change it for another situation. You have to stick with it. You say my definition is male is 2, female is 1. My definition is failure is 0, success is 1. According to this, you can say my expected value is that. Okay, you can change it, but you have to be consistent in your practice. Okay, so in terms of the variance arkadaşlar, variance is like x minus expected value. I have to find out the difference between my value and average. Okay, for example, I have 1, 2, 3, 4, 5, 6 rolling a die example, and I had the probability is 1/6 for each possible outcome. Okay, and I found out expected value is 3.5. How should I do it? I will come and say 1 minus 3.5, 1 minus 3.5 square times, okay, the probability, 1/6. Okay, this minus this times the probability plus 2 minus 3.5 squared times 1/6. Again, the probability. Okay, so if I add all these up, I'm going to find out 3 minus 3.5 squared and so on. This is how I find the variance of a random variable. Okay, if my values are spreaded over, okay, for example, it is between 1 and 100, and my mean is, let's say, expected value is 50, the variance can be very high. If my values are between 40 and 60, and still my mean is 50, then variance is small. This one, variance is high. Okay, it all depends on your data, your mean, how spread your random variable according to your mean means the variance. Okay, variance ne kadar benim data pointlerim ortalamadan saçılmış durumda. Çok saçılmışsa varyansım yüksek. For example, in an exam, the students are taking 10, 12, 20, and so on, and also we have 95, 99, when the average is 50. In another exam, I have students which are like 45, 46, 50, 55, 60, okay? So here, the variance will be low. Here, the variance will be really high, okay? So you may get a sense of how spread your data is when you look at the variance values, okay? So please take a look at these examples, solve the examples in the in different parts of the either our book or some other resources, and you can find out the variance or expected value of a PDF. If I give you the PDF, you have to find out X times the PDF. The other one was XK times the probability of x equals xk. Okay, this was this was expected value for discrete random variables. This one, it's going to be expected value for continuous random variables. Okay, you see probability will be replaced by the PDF function. Okay, so we have different questions. You may find them out, and there will be such questions in the quiz next week, inshallah. Okay. Hope to see you next week at 8:30. We will start the quiz at 8:30, and it will be around 20-25 minutes. There will be 4 questions, and then you will be dealing with discrete random variables, continuous random variables, CDF for each, finding the probabilities, finding expected value and variance, inshallah. Okay. Arkadaşlar görüşmek üzere. Hepinize hayırlı güzel bir hafta sonu diliyorum. Cumanız mübarek olsun. Görüşmek üzere.
Hocam